Okay, so this is for question 4, vectors assignment question 4 relative to an origin. The position vector of A and B are A and B respectively, where A and B are non-zero and non-parallel vectors. The points C and D are such that OACB is a parallelogram, and D lies on the line segment BC such that it divides BC into the ratio BD is to DC, lambda is to 1 minus lambda, okay, where lambda is between 0 and 1. So from here, okay, you can see a ratio. First thing we need to do, show that the position vector of D is lambda A plus B. Okay, so what we can do is slowly we go down the question, we can try to form a parallelogram. Okay, so what we can do is, the question tells us a parallelogram, find D. Okay, so D lies on the line segment BC. The next thing you do is you need to know what BC looks like. To know what BC looks like, we need to know what the parallelogram looks like. Right, so one thing that you can easily start with is you find a parallelogram, and then you see a ratio, right? Actually, you kind of suspect that probably you need a ratio theorem. Okay, so that OACB, right? Okay, OACB, you go to easily, all you need to do, right, is you just try to draw the parallelogram. Okay, OACB, right? OACB. Okay, O. So just quickly, maybe O. Maybe O looks like that. Okay, O. A. Okay. Okay. C. Okay, then maybe like something like this. Okay, B. Alright, okay, maybe it's not a very nice parallelogram. Let me just redraw this, alright? Okay. Can OACB. Alright, then OA, this is the free vector A. OB is the vector B. Right. C and D are points such that C is a OACB is a parallelogram. D lies on BC. So D lies on BC. So D probably lies somewhere here, right? So let's call this point D. It divides BC in the ratio BD, B and D, D and C into lambda 1 minus lambda. So it's so nice. You can think of a parallel, you think of a ratio theorem straight away, okay? After that, when lambda is between 0 and 1, alright, so you can see, I'm just going to use a green ink to show you that we are just going to use, ratio theorem, alright? So the position vector of D, alright, OD, using ratio theorem. Okay, quickly you can actually see that, ratio theorem crisscross, right? B to 1 minus lambda, and OC to lambda, right? So you use ratio theorem, you know that, okay, I can do this, right? So this is OB multiplied by 1 minus lambda plus lambda of OC, alright, is over lambda plus 1 minus lambda, which is just 1. Okay, and very quickly, what is OB? Oh, okay, OB we know, right? It's just the let's put 1 minus lambda and B, right? What about OC? OC, right? You see, right? Okay, over here, right? AC, OB, OC, right? It's just actually equals to OA plus AC, right? The triangular law addition. So very quickly, you can say OA plus AC, right? What is AC? AC is just equals to B, right? Because they are parallel. Oh, it's just parallel. The AC is equal to parallel. Oh, so with that, I can say actually OC just equals to A plus B. Alright, so this is just A plus B. Don't forget your fundamentals of vectors, right? So A plus B. So this is lambda A plus B. That will be your OC. Okay, the denominator lambda plus 1 minus lambda. So these two will cancel off. So just give you 1. Alright, so we don't even need to write the denominator. Okay, simplifying this, okay, you're just going to get B minus lambda B plus lambda A plus lambda B. Okay, then you can see lambda B cancel off, so you're left with lambda A plus B, right? You just say with lambda A plus B. Okay, so that's how you prove part A. Okay, then part B. Part B, we need to show that the cosine of the angle OBC is in terms of A and B. To find the cosine of the angle OBC in terms of A and B. Okay, cosine angle OBC, very quickly, we think about it. This is O. Visualize, okay, OB. Is OC, alright? So B here. C, what is OC? OC we know is A plus B. Okay? So Okay, so using our scalar product, we know that cosine theta, let's say call it theta, right? This will just be equals to OB scalar product with OC over OBC. Oh, sorry, wrong. Okay, so OBC. So you should look this way. OB. Alright, then if it's OB, this one should be negative B, huh? Okay. Then BC. Also wrong. Okay. Right, so this should be wrong. Okay, so this is OBC. So you should have BO. Remember, two tails pointing out, dot product with BC over the magnitude of BO over magnitude of BC, then it's equals to the cosine theta, right? After that, from here, we need to find angle. So let's look carefully. Okay, so what's BO? BO is a negative B. What's BC? From here, we go to the side, you just do a bit of working. BC is equals to OC. That's OB, OC minus OE, what's OC? OC is A plus B, right? Right, what's OB? OB is just equals to OB is just equals to B, right? So it's just equals to A, right? And you can actually go back to the diagram, you can see BC over here. This is also parallel to A, right? So that's why it's just A. Okay, so with that, you have this is equals to, this equals to BO negative B, dot product with BC. What's BC? BC is just A. Okay, what is BO and BC? BO will just be the magnitude of negative B. BC will just be the magnitude of A. Okay, with that, you have you can just pull out the negative sign. You take the magnitude of negative B, right? This is actually just the same as the magnitude of B as well. And look at A is just itself, and B dot A, right? So what is the cosine of OBC? What is the cosine of OBC? Yep, it's just equals to the dot product of B and B dot A over the magnitude of BA. Okay, then the last one, I want to look at show that the area of the quadrilateral OACD is 1 minus lambda over 2, then vector product of A and B. Okay, so what is area of OACD? Area of OACD. Okay, area of OACD, right? Let's go back to this question. Maybe I use another ink just to show. How about I use orange? Okay, maybe very bright orange. Okay, so OACD looks like that. Okay, this is our OACD. Right, this is our OACD. This is our OACD. Okay, can okay, I want to show that the area of OACD, okay, is equals to 1 minus lambda. Okay, so one way to look at it is we can also say that this OACD, right? This OACD, I can say that this this quadrilateral OACD, it can be the area of this, right? It can be equals to the area of OACB, subtract away this small portion, right, which is ODB, correct? Triangle ODB. You can say that, right? Okay, so I'm just going to rewrite this. I want to go to the side and redraw this in a neater format. O, A, C, right, and D, and this is B. And if you were to use to find the area of this quadrilateral, what we can do is that the area of OACD is just the same as the area of OACB. Subtract away the area of triangle ODB. Alright, and all this area, right, what comes to mind? What comes to mind should be vector product, because in vector product you have studied how how to use vector product to find area of a triangle, area of parallelogram. Okay, OACB, as you know, what OACB? OACB, quickly you can just OACB, right? If you draw this to the side, OACB, you can just take OA, OB, right? So this is just equals to vector product of A and B. That's all. Right, easy. What about ODB? ODB. Alright, ODB. Okay, ODB. If you go to the side, I just draw it again. ODB. ODB. Okay, I can just use probably OB and BOD. Okay, so this is just subtract away. This is half, right? And it's OD. What's OD? OD, as we know, is equals to lambda A plus B. Alright, and we want to vector product this. Okay, then after that, from here, right, it's just a negative half. What we can do is we can actually also pull out the lambda. Alright, so you just have a lambda over 2 A plus B, scalar product B. Okay, so based on your properties, right, this can also be rewritten as A times B plus, let me erase all these irritating things caused by my hand, okay, plus B times B, right? Right, so all you do is we just like some sort of distribution, right? A times B, A times B, okay? So you know this from your notes. Your notes tell you that A plus B times B is A times B plus B times B, okay? Over on the right hand side, just continue to write down vector product A and B. Okay, and next, right, you can see what is B times B, right? So because B times B, what is B times B? It just give you, B times B just give you 0. Alright, again, I just want to, because you can see this B is parallel to itself, right? So your vector product, two parallel vectors, is just going to give you 0. So give you 0, right? So you can just cancel it away. Okay, and you can look now, we're almost there, So we have A times B, right? Minus lambda over 2, A times B. And if I were to purposely put, like a factor 1 here, right? So you just factorize out. This is the common factor now. I'm just going to remove it, put it outside. You have 1 minus lambda over 2. And you have vector product A and B, right? And we are done for question 4.